Hey everyone, I'm teacher Mesa, grade 12 calculus teacher. Welcome to our first virtual class. This is section 6.5 of your calculus textbook. Our topic of the week is the trapezoidal and the Simpsons rules. These are alternative ways of estimating the definite integrals of some functions whose antiderivatives are not easy to obtain. As you remember, in the earlier section of this chapter, we defined the rectangular approximation method, and we used it to help us introduce the definition of integrals. We have seen three different ways of rectangular approximation method, namely the right rectangular approximation method, the midpoint rectangular approximation method, and the left rectangular approximation method. Of these three, the midpoint rectangular approximation method gives us the best approximation of the integral or the areas of a given irregular shape. Now, we will be using a trapezoidal rule, which is another alternative way of estimating the definite integrals of functions, a function whose antiderivative is not easy to calculate. It is stated as follows. For a regular partition of an interval a to b with n subintervals, each of which delta x equal to b minus a over n, the definite integral of f of x from a to b is approximated by the formula delta x divided by 2 into f of x naught, 2 times f of x1 plus 2 times f of x2 plus all the way to 2 times f of xn minus 1 plus f of xn. Here, delta x represents the height of the trapeziums formed upon partitioning the given region, and it is calculated by the formula b minus a over n. The difference b minus a is simply the value obtained by subtracting the upper limit of integration minus the lower limit of integration. Now, let's see some examples to help us understand how we can use the trapezoidal approximation method. Example 1. Use the trapezoidal rule to approximate the definite integral of x cubed from 0 to 3 with n equal to 6. So we have to divide the interval from 0 to 3 into 6 subintervals, 6 equal subintervals. To help us solve this problem, let's use the number line. On your number line, place the lower limit of integration, which is 0, on the leftmost of your number line, and number 3, which is the upper limit of your integration, on the rightmost, and divide the region between these two extremes into 6 equal subintervals. And you can do that one by finding the difference 3 minus 0 divided by n, which is 6. So 3 over 6 is 1 over 2 in its simplest form. And the next step is to find the coordinate of all the 6 partitions in between 0 and 3. How you can do that? You have already obtained delta x equal to 1 over 2. So you add up this 1 over 2 onto 0. So 0 plus half gives you 0.5. Again, to see what comes after 0.5, you have to add 1 over 2 to 0.5. That gives you 1. 1 plus 1 over 2 is 1.5. It goes on until you reach the last upper limit of integration, which is 3. The next step is to write the formula for the trapezoidal approximation method. Plug in delta x, plug in 1 over 2 in place of delta x, and in place of x naught 0, in place of x1 0.5, x2 1, x3 1.5, x4 2, x5 2.5, and x6 3. And by properly calculating the functional values and using your calculator, you can get the approximate figure is 20.8123. Now let's move on to looking into the second part or the second approximation method of this section. It is the Simpsons rule. This rule states that for a regular partition of an interval from n to b, with n equal subintervals, each of which delta x equal to the difference b minus a divided by n. The definite integral of f of x from a to b is approximated by delta x divided by 3 into f of x naught plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3 plus it goes on, alternating 2 and 4 as the coefficients except the first and the last ones, and then you end up finally with f of xn and close your bracket. In Simpsons rule, we have to take note that the value of n must be an even. Okay, let's see the second example of the lesson where we can approximate the definite integral of the reciprocal function 1 over x from 3 into 5, but this time we'll be using the Simpsons rule. As before, we start our calculation by finding delta x equal to b minus a over 6. The difference b minus a is 5 minus 3, which is 2. 2 divided by 6 simplifies to give you 1 over 3. And now we have to use the number line. On your number line, place the lower and upper limits of integration on the left and rightmost respectively, and partition the region in between these two numbers into 6 equal subintervals again, because we are given the value of n to be 6. And then you have to write the formula for the approximation of this definite integral. This time we'll be using delta x divided by 3. Our delta x is a third. So you have to divide this a third into 3, or 1 over 3 divided by 3, into f of 3, that represents f of x naught, plus 4 times f of 10 over 3, where 10 over 3 is f of x1, and you continue alternating the coefficients between 4 and 2 until you reach the last one, f of 5. Okay, properly plugging in all the values into your calculator and formula, and then you can get the figure 0.51082999108. This is the figure that's displayed on the screen of your calculator, but the answer can be limited to a few decimals depending on how it's required. Now let's move on, comparing the trapezoidal rule and the Simpsons rule. Note that the formulas are very similar in construction and differ mainly in the coefficients used in the summation. The multiplying factors are also different. In the trapezoidal rule, the multiplying factor is h over 2 or delta x over 2, and in Simpsons rule, we are using h over 3 or delta x over 3. Simpsons rule is usually much more accurate, as we will be looking into this fact on the upcoming example.